Hello guys, Tomatho here with another geometry question. This time it is an Oxford Math Admission Test question. Can you solve it? The problem statement is, the triangle ABC is right angled at B and the side lengths are positive numbers in geometric progression. It follows that tangent of BAC is either. So yeah, here are the choices of answers. Here are the hints for this question. As usual, the hints are progressive, so the latter hints will be closer to the actual answer. Feel free to pause the video at any point of time if you found inspiration from it. So the first hint, the three sides form a geometric progression, right? Can you use variables to represent the length and deduce which is the hypotenuse? Something like this. Next, there is one well-known theorem that states the relation between the three sides of a right-angled triangle. Try to use it if you know what it is. So yeah, here is the solution. Let's assume the three sides is S, SR and SR square, where S is greater than 0 and R is greater than 1. This assumption is done so that we can determine which is the hypotenuse. In a right-angled triangle, we know that the hypotenuse will always be the longest side, right? So the hypotenuse here must be SR square. From here, there are two possible arrangements of the right-angled triangle. The first one is when AB is shorter than BC. In this case, the length of AB and BC is S and SR. Thus, the value of tangent BAC is SR divided by S, which equals to R. The second case is when length of AB is greater than BC. So, the length of AB will be SR and the length of BC is S. In this case, the tangent of BAC equals to S divided by SR, which equals to 1 over R. So, there are two possible values of tangent BAC, and clearly, we have to find the value of R to get the value of tangent BAC. Well, how can we do that? Remember that this is a right-angled triangle, right? We can use the famous Pythagorean Theorem to obtain another relationship among these sides. So to recall, the Pythagorean Theorem is as follows. Where C is the hypotenuse, the theorem states that A squared plus B squared equals to C squared. So, by applying this theorem to the triangle that we have the following equation. Simplifying it, and given S is greater than 0, hence S squared is greater than 0. So we can divide both sides by S squared. This gives the familiar quadratic equation, where the roots is R squared. This is because we can rewrite it as follows. Now, this quadratic equation is not factorable, so we must use the completing square technique or the quadratic formula. In this video, we will be using the quadratic formula. So, to recall that this is the quadratic formula that we will be using. So, applying this formula to our equation, we have R squared equals to as follows. So, simplifying it, we have R squared equals to 1 plus minus square root of 5 over 2. Given that R is greater than 1, hence R squared must be 1 plus square root of 5 over 2. So, the value of r is equals to square root of 1 plus square root of 5 over 2. Earlier, we know that there are two possible values of tangent BAC, right? Which is r and 1 over r. So the two answers will be square root of 1 plus square root of 5 over 2 and 1 over square root of 1 plus square root of 5 over 2. But wait, our answer here is not in any of the choices, right? So what's missing? Well, don't be afraid, because we have to rationalize the 1 over r. So to rationalize it, we shall multiply the numerator and denominator with its conjugate. So the conjugate is square root of 5 minus 1 over 2 here. So 1 over r equals to square root of 5 minus 1 over 2. Thus, the answer to this question is C. Do you manage to find the answer? Let me know in the comment section below. Thank you for watching. Give a thumbs up if you like this video and subscribe to my channel if you would like to see more interesting math video.